Hi there everybody, today we're going to look at combinations and sample spaces. Alright, so this is about information that sometimes it's worthwhile putting into a table to kind of support you in terms of what you're looking for, but other times it's just looking about what kind of potential combinations you've got to assess what you need to do with a particular question. Alright, so you may be asked to literally list a different number of combinations. So that means you're going to have to write down all the potential possibilities and therefore gleaming what you need to do to find an outcome. All right. It is obviously best to work through things methodically. Kind of common sense to suggest that, but sometimes when you're in a pressure situation, certainly when you're kind of sitting an exam, the idea of thinking methodically sometimes thrown out the window. But of course, you must sometimes think, well, I've just got to go through this process and do it. All right. So here's an example. Sandwiches are sold in either brown, white, or seeded bread, and you can either have cheese, ham, or tuna. Write down the possible combinations of sandwiches. All right. So if you think about it, that means you could have a ham sandwich on brown. You can have a tuna sandwich on white. You can have a cheese sandwich on bread, etc., etc., etc. All right. Now we're not looking for combinations of cheese, ham, and tuna. All right, that's going to get even more complicated if it talks about two toppings. I think specifically we're just focusing on it's going to be either cheese, ham, or tuna on either of those three breads. All right, so your best bet is probably put some letters to it. So if you look at this one very, very carefully, so brown, white, and seeded, so maybe B, W, and S, and then for cheese, ham, and tuna, maybe C, H, and T. All right, so if we've got, for example, start with brown bread. That means we're going to have brown with cheese, ham, or tuna. All right, they're first options. And then we're going to repeat it with white. So you're going to have white with cheese, white with ham, and white with tuna. Or, of course, you can have seeded bread with cheese, ham, or tuna. All right, so there are 9 possible combinations from that, as you can see from there. 3 different options for 3 different beds. All right, so write down the possible combinations of sandwiches. Well, that's your lot. Now, we haven't asked you any further questions on it, but of course, you would accept potentially in an exam, they might then say to you, well, how many different combinations be? How many ways can you have ham, etc., etc. So there might be something in relation to, well, how many ways could you have ham or tuna kind of thing? And then you would look at the numbers you've got and decide, well, it's something out. So what's the probability of having something with ham on it? Well, it's 3 out of 9. All right. And again, if it was random combination. All right. Well, let's kind of move on to sample spaces, because this is that idea, but formalized in a table, really. So hence they call it a sample space. So your sample is all the possibilities and all the different kind of combinations that you're going to get. All right. So here you go. Sample spaces is the list of possible outcomes of specifically 2 events. All right. So rolling a dice and a simple spinning spinner. All right. So in terms of obviously the sample space, is that you're going to put the combinations of the dice on one side and the combinations of the spinner on the other. All right. So what is that going to look like? So if you've got a 6-sided dice and the spinner is numbers 1 to 4, then you're going to have a dice on the top, then you're going to have a spinner on the bottom. And now it says in the question here, 6 dice is rolled as a spinner and numbers 1 to 4 is spun. The scores are added together. All right, so that's the key bit here. The scores are added together and record the possible outcomes in a sample space. All right, so we're going to basically roll the dice, roll a spinner, and then we're going to add whatever we get. And we're going to see what potentially we can get from doing that and how many different outcomes I can get. All right, so you've got the table kind of set up, and then we just need to fill it in. All right, so fill it in. So 1 plus 1 is 2, 2 plus 1 is 3, 3 plus 1 is 4, 4 plus 1 is 5, and 5 plus 1 is 6, and 6 plus 1 is 7. So we're adding this one and this one, that one and that 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 one, and that one and that one. And all these boxes in there kind of are literally adding up. All right, so now I'm going to do this one plus this one to get this, that one to that one to get that, that one to that one to get that, and so on and so on and so on. So we'll just kind of skip all that. You're going to end up with a table looking like that. And we could just check. So 6 and 4 is going to give you 10. All right, just by kind of looking at that. Okay, so that's your sample space. Effectively, we haven't answered any questions on it just yet, but that is your sample space. So if we are going to use a sample space, then the chances are they're probably going to ask you probably some kind of probability-based question on it. All right, so if I just go back a second, then they might actually say, well, how many ways can you get a 6 from doing what you've just done? Well, if you look at this kind of question here, there was 1, 2, 3, 4 ways you could get a 6. All right, and of course, there's lots of different combinations, but we're going to look at that one now. All right, so calculate the probability of scoring a 4. All right, so we are going to do it with the same situation. So how many different ways are there? How many potential outcomes where there are 4, 8, 12, 16, 20? There are 24 possible outcomes. All right, you've got 6 along the top, 4 along the bottom. So there are 24 outcomes. So therefore, it's out of 24. So how many 4s though? 1, 2, 3. So it's going to be 3 out of 24 is my probability. And the 3 ways of getting a 4, and there are 24 different outcomes, all right? So out of the whole lot, which is just kind of highlighted there for you. So 3 out of 24, all right? They simplified it in this case, but we are talking probability, so you didn't necessarily need to do that. So scoring more than 7. So you're looking at how many numbers are more than 7. So let's kind of count them. So you've got those 6 there are more than 7. All right, be careful with the kind of question here. It doesn't say more than or equal to 7. It says more than 7. So it's those 6. And again, as before, it's out of 24. All right, so 6 out of 24. So that sample space there, just by putting it all together, is going to support you in terms of what you need to do. All right, because it talks about all the different combinations, all the different kind of possibilities, all the numbers that you potentially get, puts it in a table, and then from there, it's actually quite relatively straightforward. All right, sure, it simplifies that one at the end. Okay, so that is sample spaces and probabilities from sample spaces. Please go to maths-school.co.uk and have a look at the kind of questions which are on there for some additional kind of practice. And I will catch up with you very soon. Thanks for listening.